Assalamu alaikum. In this lab session, the method to perform the modal analysis for this example 2.5 of mechanical vibration by SS Rao will be explained, and we will be learning the method to determine the natural frequency of a pulley system. So this example has been used, and where it says that determine the natural frequency for the pulley system shown in the figure, and assume that the pulley is to be frictionless and of negligible mass. So the pulleys have been described to be of negligible mass, and also the cables are also massless. So this is the schematic for the diagram. This is the pulley 1 and pulley 2, and in this way these two movable pulleys have been used, and two springs of stiffnesses K1 and K2 have been used, and the point mass is attached here, and under the initial excitation of this mass in the downward orientation, this system oscillates about its mean position, and it is required to determine its natural frequency. So first of all, the requirement is to determine that's equivalent stiffness. So the equivalent stiffness has been derived here. So this is the final derived formula for the equivalent stiffness for this whole system, and this is the circular frequency in radian per second in terms of parameters, and this is the linear frequency in cycles per seconds or hertz. So we will have to assume data. For example, we can assume the stiffnesses K1 and K2 to be equal, and each stiffness is to be 2000 Newton per meter, and this linear frequency we can assume it to be 5 hertz. So using this formula, we will be inputting the values of K1 and K2 and this linear frequency, and we will be determining this point mass. So end mass will be calculated, and when it is calculated, this comes out to be 0.2533 kilogram. So in this way, you can make calculations and verify it that this end mass or point mass comes out to be 0.2533 kilogram. So first of all, we will be now creating the geometry for this model. So we will be launching model module by simply selecting and dragging it here and releasing the cursor, and after that we will be straight clicking on geometry cell A2 A3, and we will be waiting for it to load, and once it has been loaded, as we can observe that the design modeler has been loaded. Now we will be creating the scheme model for this problem. So from the schematic we can observe that this model will be created. As we can observe that a single cable is wrapped around these two moving pulleys. So for the purpose of our analysis, we will be splitting this single cable into three independent individual cable segments. This cable segment is the leftmost portion, and this is the central or middle portion, and this is the right most portion. So we can we will only be creating the portions of the cable which are in the vertical orientation. We will not be formulating or modeling the portion of the cables which have been wrapped around these pulleys. So we will only be creating three line cable segments. So the dimensions for each cable segment assumed are that that this leftmost portion of the cable, its total length from this point to this stationary surface is 20 meter. This is only assumed data. And this central cable portion from this point to this point, vertical portion, this is assumed to be, for example, 5 meter. And here, this rightmost portion of the cable from this point to the point of attachment of mesh, this is assumed to be 15 meter. Further location will be explained while modeling here. So we will be selecting XY plane first of all, and in the XY plane we will simply be clicking on sketching tab, and in the sketching, as we can observe that XY plane has been selected. Now we can set it in the planar view by clicking on this icon, look at face or plane sketch icon, or we can click on this positive Z axis like this. And now we will be creating this left portion of the cable. So select on, click on line, and we assume that this middle portion of the cable, its lower point is on the origin and its upper point is on the y-axis, and this whole cable is along y-axis. So first of all, we can create the central portion. For example, this is we can dimension it to be 5 meter as it has been assumed. So here the parameter V1 is shown and we can set it to be 5 meter. After that, we will be creating next line using line command, and we can start it here. And as soon as vertical constant is shown, we will be clicking and the vertical line will be drawn, and we can dimension it to be 20 units. Remember that these are just assumed dimensions because the cables are massless, so any dimension can work. These all dimensions have been assumed by only observing the schematic diagram. So also the distance between this middle cable and this leftmost cable is actually the diameter of the pulleys, because the gap, this gap is actually equal to the diameter of this pulley, and the distance between this rightmost cable and this middle cable, this is also equal to the diameter of the pulley too. So as these both pulleys are of equal radius, so what we can do, we can dimension at this stage using horizontal dimension, and distance between this point and this vertical line, this distance we can write it here, this distance to be 4 meter. So the diameter is 4 meter, that means the radius for each pulley is 2 meter. So but we will not be creating the diameter pulleys in this sketch. We will be creating the diameter for the pulleys in a separate sketch, because if we create in the diameter for the pulleys in this sketch, so this will become an integral part for the sketch 1, or that will be connected along with the cable and will be treated as a single sketch. So to make them distinct from the cables, we will be creating the diameter for the pulleys in a lateral sketch. So after that, we will be creating this rightmost portion of the cable. So click on line command here, and in this way, this vertical portion. And remember, we can assume that the as the elevation of these 2 points is same, because this point and this point, the elevation of these 2 points is also same. So we can assume that the portion of this rightmost cable above the x-axis is to be same as the distance or dimension for the central portion of the cable. So this dimension is must also be 5 units, so that these 2 points are at the same elevation. So, and we can also set the total length for this cable to be 15 units. So that means below the x-axis, this portion for this rightmost cable is 10 units. So this is 5 units and this is 10 units. So total 15 units has been created. And again, between these 2 points will be the diameter of the pulley. So we can use horizontal dimension and click on this point and this point, or vertical line for example, and we can set this distance to be same as 4 meters. So in this way, 3 pulleys have been the cables have been created. Now we will be clicking on this plus sign, and then will we be selecting sketch 1, and after that we'll click on concept menu, and then click on line from sketches, and then click on apply. And we can observe that 3 parts, 3 bodies have been created. And remember, 3 line bodies have been created because there is no connection between them. They are made independently in the single sketch. If they were connected by some line segment, they would be converted into a single body and single pod. So as there is no connection between these 3 cable segments, so each segment has been created as a individual body. So after that, the next task is to assign the cross section. We can assume a circular cross section, and the circular cross section here we can observe that this default diameter is very small. So we can dimension it to be, for example, 0.2 meter will look sufficient. Remember that this radius dimension is just a representation and it does not affect usually our analysis results. So now we will be assigning these cross section to these line bodies. So we will be selecting here the same circular cross section, and in this way the section has been assigned. After that we can click on view and into cross section solids, and then we will be making display plane off, so that we can observe that 3 cable segments have been created. Our next task is to create the portion for pulleys, and remember that we are not required to create these circular pulleys exactly. We will only be creating the diameters for these 2 pulleys. So to create them, what we will be doing, we will be creating selecting XY plane, and then we will be clicking on this new sketch option from here, or we can click on create here. In this way, uh, we can create a new sketch. Here we can click on here, and in the same plane, XY plane, a sketch 2 has been created. So we will be selecting the sketch 2 and click on sketching tab, and after that we can for the time being make this cross section solids off, and After that, we will be clicking on this line, and here we can be we can create two line segments of random length. And as we can observe that the diameter of each pulley is 2 meter, radius of each pulley is 2 meter, and diameter is 4 meter. So what we can do, we can randomly create radii, and after that we will be using constraint here, equal length constraint in this way, and we will be making these two lines to be equal, and also these two lines to be equal in this way. Each line is of length 2 meter, so otherwise we can simply dimension them, e- each individual radius to be 2 meter. So after that, what we will be doing, a very important step, that we will be clicking on sketch 2, and in the same manner click on concept and line from sketches, and here we will be clicking on apply. And very important point to be noted here is that here the operation must be add frozen instead of add material. We will not be using add material, we will be using add frozen, because if we use add material, then this radius will be merged with this cable portion. So each radius will be merged with the cable portion, and it will be treated as single or connected body, and there will not be any distinction between the pulleys and the cables. So to make them distinct and having their entity as a separate bodies, we use add frozen property. So the purpose of add frozen property is to create distinct bodies when they have connections, like the assemblies, we can say. So add frozen, after that we will be generating, and we will be observing here that two further line bodies have been created, and total 5 parts and 5 bodies have been created. And remember, the same cross section can be assigned to the these radius, because we don't require to create a separate section for these pulleys. So the same section can be assigned. That doesn't affect at all our analysis. So in this way, if we make this display plane off, we, and furthermore we can, if observe this cross section solids, if we make them visible, then this is the required complete model which has been created for this system of pulleys and cables. So this complete model has been created, and geometry creation step has been created. After that, we can either close this design modeler, or we can leave it open, so that if we want to change something, so we will not be required to load it again. So we can minimize it, and we will be launching the model cell A4. But before this, we can click on model cell A2 and click on engineering data. And because here we can observe that it has been mentioned that assume that the pulleys to be frictionless and negligible mass. So the pulleys and both the cables each is negligible mass. So to make them of negligible mass, we can change the density here to be 10 raised power, for example, minus 40, which is a very, very small value, or you can use any smaller value. So I am using 1e minus 40. So, so this is the 10 raised power minus 40 units density. So after that, we can click on model cell A4, and we will be waiting for it to load. As we can observe that the model has been loaded, we can further show it here using cross-section solids, and we will be looking from the Z orientation. So the model has been highlighted and loaded, and after that we will be clicking on geometry and expanding and checking its properties, whether it has been made mass less and of negligible mass. We can observe here that the value is very small for the mass for each segment, so as we can observe. And after that, our the first simpler task is to create a point mass which has been calculated, and we will be applying this point mass at this point. So click on point filter and click on at this point and then click on apply, and here the calculated mass is to be 0.2533 units for frequency of 5 hertz. So this mass has been applied, and after that, here we can observe that a connection has been added. So as there are different bodies, so we will have to create connections between them. We will be creating connections like this. For example, between these pulleys and these cables, there will be connections. So as these cables are free to slide along the periphery of these pulleys, so the connection between these pulleys and these cables will be of revolute joint, not the fixed joint. So between each cable and between each pulley, the connection will be revolute joint at the connection point. So how that will be created? So remember, there are many techniques to create the connections. What I will be using is that what we can do, that we will, for example, first of all, we can make this cross sections. We can set it in wireframe mode here like this, and we can uh, make this cross solids off, so that these lines have been highlighted. So this is line body, this is line body. So first of all, we will be selecting, for example, we will be creating a connection between this radius and this cable, leftmost cable. So we will be, for example, hiding this leftmost cable. So this has been made hidden, and after that we will be clicking on here connections, and here we will be clicking on joint, and here connection type is body dash body, because the connection between two bodies is being made, and here the type must be revolute. And here in the reference, here are two portions, one is the reference and other is the mobile. So in each of these portions, in the reference and or in the mobile, we will be defining the scope portion. So click on scope here, and then what we will be doing, we will be clicking on this point filter, and then we will be clicking at this point, because this is the left most point for this radius of the pulley or connection point. So click at this point here and click on apply. And remember, it is very important that this connection or this point must be located in XY plane, and Z axis must be perpendicular while applying the connections. So the first point has been selected of this radius, and after that what we will be doing, that we will be making this line segment to as show body, and we will be making this line body as the hidden body, so that the same point is selected on the different bodies, then we will be going to next point in the revolute joint, and then we will be clicking on mobile, and here we will be clicking on this point, and in this way we can observe that green tick mark has been highlighted, so the connection is successful, a revolute joint has been created. So in this way the joints will be created. So after that we will be creating next joint in a similar manner. So as this body is here, we are actually high, as we can observe that the connection point is actually the common between two bodies. So we first make hidden one body so that the connection, the same point is selected on individual or distinct bodies. If we don't make hide one body, then the same point will be selected on same bodies, so the duplicate point will be selected. So to avoid this, we actually temporarily hide one body so that distinct point on different bodies are selected. So in this way, what we will be doing, we will be applying the next joint. So change is type to be revolute joint, and in a similar manner as the other joint will be here at this location between the lower portion of this central cable and this radius of the pulley. So here we can click at this point, and then we can click on apply here like this, and again we can, for example, mm, mm, we can show this radius of the pulley, and we can uh, hide this central portion of the cable temporarily so that the same point is selected on this radius. So it is very important. So again click on the respective connection here and go to the mobile portions. So when the connection is between uh, two bodies which are relatively in motion in each other, then it doesn't make any difference that which one is the reference and which one is the mobile part. So click on this point and then click on apply, and as we can observe, another revolute joint has been created. And in a similar manner we will be creating a third revolute joint here between this pulley end at this location of the cable, upper portion of the central cable. So here again, as the central portion is invisible, so we can use it here. For example, in the reference point we can use this location here, and we can click on apply, and after that we can uh, make the central portion of the cable as visible, and then we can make it of this right diameter of the pulley, and in this way then again we will be clicking on here at the same point at the cable, and remember, never forget to change type to be revolute. So now we will creating the last revolute joint here in this manner. Here the last joint will be made here, revolute joint between this uh, upper portion of upper point of this cable, left rightmost cable, and this radius of the pulleys. So what will be done, that we will be clicking on scope, and here at this location, and after that, in a similar manner, we will be doing, we will be highlighting or showing this radius and the this making this portion as hidden, and then again click on this portion and then click on mobile and click on the same point on this radius. So as we can observe that the connection has been created successfully, but remember the change the type to be revolute. So we can observe 4 revolute joints have been created between the connection between the radii and the cables. So first revolute joint was here, second revolute joint was here, third revolute joint was here, and fourth revolute joint was here. So in this way, 4 revolute joints have been created. So so our next task our next task is to create these two springs of each having stiffness K1 and K2. So let us create these two springs. So right click on connections and click on insert and click here on spring. So here the stiffness for each spring, as it was mentioned, it is assumed to be 2000 Newton per meter linear spring. And here we must observe that both of these two springs at one end of the spring is along the reference or ground, and also for this lower spring, this lower portion is also along the ground. So we will be using body dash ground option instead of body dash body. So we will be clicking here body dash ground, and then we will be going straight towards mobile portion, not the reference portion, and we will be clicking scope in the mobile portion, not in the we will not directly be inputting these reference coordinates. So first of all, we will be clicking on scope, and the scope will be this point. So click on point filter and then click on this central portion of this left pulley. So click on apply, and as we can observe that the spring has been assigned, but now we have to realign the spring. So here we can observe the coordinates of the mobile, that x is -2, that x is -2, as we can observe here. We can observe from the geometry that if we would click on xy plane, so this was actually the y-axis, and this was actually the center of the pulley. So this was towards negative x-axis -2 units, because the diameter for the pulley was 4 meter. So this point was -2 units along negative x-axis. This was the origin. So in this way we can observe that this is -2, and the y coordinate is 0 because it was along on x-axis. So what we will be using, if we have to vertically align the spring, we will be using the same x coordinate here for the reference portion -2, and after that we will be defining this reference coordinate or y coordinate. So y coordinate will be setting the length for the spring. So we can observe that the length for the spring here from this, starting from this point. So as we can observe that the portion for this cable below this x-axis was 10 units. So we can, for example, set the length for the spring to be uh, 10 units. So it will be negative 10 units. We can put here negative 10. So below y-axis. So we can observe that this spring, remember the length of the spring does not affect our analysis of the result of the analysis. So in this way, or we can use, for example, minus 10, or for example we can use minus 15 in this way, so that it to make it more visible. So in this way, now we will be creating the other spring. So the stiffness is same 2000, and again it is actually body dash ground. So again go on the scope in the mobile, and then now click on this point here and click on apply, and now note its coordinate. As we can observe that its x coordinate is 2 meter, as we can observe from that this point is positive 2 units along x-axis, positive x-axis. So its y coordinate, as we can observe that this is 5 units. So we want the location of this spring is along the same elevation with this leftmost cable. So the distance between this point, center of this pulley, and this stationary surface, the distance is to be 15 units, because the central portion cable was 5 meter. So this whole cable was 20 meter. So this above portion is 15 meter. So but the distance will be measured from x-axis. So we can input here that the x coordinate here in the reference portion, in the reference portion the x coordinate is 2, and the y coordinate is 20 meter. So in this way, as we can observe, these two springs each having stiffness k1 k2 has been assigned. Our next very important task is to assign the constant and analysis setting. In the analysis setting, as we can observe that this is a 1D problem, so its mode must be 1, and after that we will be setting is further constant. So we will be constraining these 3 cable portions, because these 3 cables are constant to move in the vertical planes along y-axis only. So we will be using 3 remote displacement for these 3 individual cable segments, and 2 remote displacement for these diameter of the pulleys. To so total 5 remote displacements will be used, and one fixed support at this location will be used, and one displacement support at this mesh point will be utilized. So let us apply these constant. So click on model, and then click on remote displacement, and then we can select using point edge filter. Click on this edge, and then click on x is equal to 0, and y must be free and z must be 0. And remember only y must be free and all other parameter must be 0, so that its DOF is confined, and here its behavior must be rigid instead of deformable, because so that the true deformation is highlighted. So remote displacement along this, we can rename it remote displacement. For example, uh, for left cable, remote displacement for left cable. And in a similar manner, we can insert an other remote displacement. Remember, we can duplicate one remote displacement to falsely apply for the other cable portions, but it is better that we can individually apply them, so it will not take much time. So click on this central portion of the cable and then click on apply, and then make in a similar manner this coordinate 0 and this coordinate 0, this coordinate 0, this coordinate 0, and only y is free and all other coordinates have been made 0 in this way. So we can also rename it that for middle cable, and again we can select apply third remote displacement for the rightmost cable. So click this cable, and here must be 0, then this must also be 0, then this must also be 0, this must also be 0, this must also be 0, and the behavior must be rigid. So we can just optionally rename it for right cable, and further we can insert another remote displacement for the diameter of the pulleys. So let apply the remote displacement at this diameter. So click on this radius and then click on by control pressing. If you want multiple selection, you will be pressing control button. So click on apply as two edges have been selected. And remember, it is very important to note that although these pulleys are in pure rotation, but we must be input the coordinate here. X component and Y component must be free, so that these points are free to move in the X and Y orientation partially. So X must be free, Y must be free, and Z must be 0, and rotation along X must be 0, rotation along Y must be 0, because any axis in the plane of the body, there is no rotation about that axis, and after that rotation about Z must be free. So here its behavior must be rigid. So we can also rename it to be, for example, remote displacement for center of left pulley. So in this way we have renamed it. So after that we will be applying another remote displacement constant for this right pulley. So click on apply and two edges have been selected, and In a similar manner, we will be inputting these coordinates. So behavior must also be rigid. So we can also rename it for center of right pulley. So in this way, 5 remote displacement, 3 for 3 cable segments and 2 for center of the pulleys have been. And after that, we also know that the center of these pulleys are constant to move vertically downwards or upwards. So we must confine them. So click on insert and then displacement, and then click on, for example, this point filter, and then click on this point and click on apply, and then make x component 0 and y component must be free so that it can move along vertical. And we can rename it, for example, displacement for center of left pulley. And in a similar manner, we can observe or insert the displacement for the right pulley center. So click at this point here, and then we can rename it to be here, that x is equal to 0 and z must also be 0 and y must be free. And we can in a similar manner rename it, for example, for center of right pulley, in this manner. So the displacement have been applied, and one more displacements constant will be made here at the location of this end mass, so that this point is constant to move along vertical orientation. So distinctively we can apply displacement at this location at the point of end mass. So in a similar manner, this must be 0 and z must be 0 and y must be free, and we can rename it displacement at mass location, for example. So we can observe that 5 remote displacement have been applied, 5 remote displacement, 3 for cables and 2 for the pulleys, pulleys radii. So these this remote displacement are the for pulley radius. So we can, instead of rename it, instead of center, we can rename it to be for the radius, so that no one is confused, because actually the edges were selected. So we can rename it to be for the radius. So total 5 remote displacement and 2 displacements for the center of the pulleys have been applied, and another displacement for the mass point has been located. After that, we will be clicking on solution, insert deformation and total deformation, and now we will be solving and waiting for the solution. And remember that one fixed support has been missing because the upper portion was to be fixed. So as we can observe that this upper portion must be applied as a fixed support. So let us apply a fixed support at this location. So insert, click on fixed support here, and then click on at this point and click on apply. And here now we will again be solving, and as we can observe that the frequency is exactly 5 hertz, and now we can observe its simulation in a similar manner. Click on total deformation, and in this way we can observe that the deformation or simulation is being made. So in this way this model has been successfully simulated and the frequency has been shown and comes out to be exactly 5 units as it was calculated. So thanks for all listening and bearing. Jazakallah. Assalamu alaikum.